Welcome back, guys. So this is a video where you're going to start actually looking at a given amount of chemical. So I've got a certain amount of chemical in this weighing boat and it's sitting over here. Hopefully the overhead camera will get it again. It's right in here. The question is, in this weight of chemical, how many moles do we have? That's the question we're trying to answer. Now it's very specific to an experimental sample we've got. So in order to be able to do that, you need to be extremely clear about what the formula is so you can identify the different elements. You need to be able to calculate the molar mass of a compound from the formula. I want to make sure that you're very clear on this. 58 grams was the molar mass of sodium chloride. Again, in this example, I'm just rounding. So the weight of the chemical I have here is approximately 2.9 grams. So that is the weight of the chemical that I have in here, and that's 2.9 grams of, and the name of this chemical is sodium chloride. So we're going to stick with sodium chloride, and all we're trying to figure out is how many moles are in 2.9 grams of chemicals. That's what we're trying to do here. So you're calculating the number of moles in 2.9 grams of sodium chloride. Your given is 2.9 grams of NaCl. So once you get good at writing formulas, it's important that you actually write the formula next to the mass. So we've got 2.9 grams of sodium chloride. What we know is that 1 mole of this particular chemical, so 1 mole of sodium chloride, is equal to 58 grams of NaCl. So 1 mole is equal to 58 grams of NaCl. Okay, and what we're looking for is, we're trying to figure out, I'm going to use all these different colors, hopefully it'll work. We're looking for the moles of NaCl. That's what we're trying to figure out. So what is the count? What is the moles of sodium chloride in this weight that we weighed out, which is this chemical right here? So in 58 grams we know, there's 1 mole. So this is what you use to create your conversion factor right here. Okay, and that is it's a constant. You can actually look these values up, but this information is what you're going to write here. And again, please remember that I'm just demonstrating this to you. This is to kind of walk you through this. In the normal course of events, you would be giving me the decimal version of this. I'm just showing you how to do this. So 58 grams, and we've rounded that number. So 1 mole, okay, NaCl is equal to 58 grams NaCl. Or you're going to flip it over and write it as 58 grams NaCl over 1 mole NaCl. So this is how you set up any question asking you to convert either from grams to moles or moles to grams. So right here you're given multiplied by your want divided by know. So please remember, your given is nothing but 2.9 grams NaCl. And what you absolutely need to remember is that this unit needs to show up in the denominator. This is what you're looking for. And it turns out that conversion factor A fits the bill. So we're going to copy this down here. 1 mole NaCl is 58 grams NaCl. In this example, in this experimental sample right here, it turned out it was 2.9 grams. You could have some random number. It is not specific. I just weighed out 2.9 grams, and there were 2.9 grams in here, and I'm just trying to figure out the number of moles in that. So this is just an arbitrary lab sample that we've got. So grams NaCl are going to cancel out. The moles stay. So when you simplify this, it's going to become 2.9 multiplied by 1 mole over 58. This is equal to, so you're going to plug this into a calculator. Okay, so 2.9 divided by 58 is equal to 0.05. So 0.05 moles NaCl is what you have. So that right there is the number of moles of sodium chloride you had in this experimental sample of sodium chloride. I hope that was helpful, and that is how you actually extrapolate the number of moles using conversion factors. So just to recap again, and this is important, so hopefully you're taking detailed notes on this. You start out with a formula. Okay, you need to be able to write the correct formula. You need to be able to read the correct formula. How many elements? You write down the split, you write down the elements. You have to understand that the moment you're looking for moles, instead of using atoms here, you would use the word moles. The weight would be in grams because you're trying to solve for a mole, not for a single molecule. 23 grams plus 35 grams gives you 58 grams. 58 grams is what 1 mole of sodium chloride weighs. This is your known. This is a constant. This is what you figured out. There are synonyms for this: formula weight, molecular weight, gram formula, mass, same diff, 58 grams. And this is specific to sodium chloride, not any other chemical. We then had 2.9 grams of an experimental sample that I just randomly poured into this handy-dandy device called a weighing boat. Not quite sure what it's doing in my study, but anyway. So you got 2.9 grams of sodium chloride in this weighing boat. The question was, how many moles is 2.9 grams? What we just solved over here is how many moles are in 2.9 grams, and the answer is 0.05 moles of sodium chloride. As always, hope this was helpful. Smack that like button. If you have any comments about how I could improve it, let me know. And as always, if it ain't chemistry, that's just stamp collecting. Bye, guys.